Hello and welcome back. In this part of the lecture, we will look into Bitcoin mining and proof of work schemes. In Bitcoin mining, the part that searches for the correct nonce is actually the Bitcoin mining. And this nonce searching is also part of more general approach known as the proof of work schemes. So what is proof of work? It basically is a computational puzzle that takes significant effort to compute, but are very easy to check. For example, we previously tried to create a message that produces SH256 hash values starting with 3 zeros. We found that quite difficult. Even finding 1 zero required some effort. So in Bitcoin mining, what the machines actually do is that they modify the nonce so that the given block has a hash value under a certain threshold. Bitcoin started with fairly easy threshold, easy for a computer that is, which means that the number of zeros in the start of the hash function result, there should be 8. So 8 zeros followed by FFFF, or value smaller than that. As you can see from the slide, current target is much more difficult. There are 11 zeros that need to be in the beginning, and then followed by some other numbers, and the value has to be that or smaller. As you can see from the slide, current target is much more difficult. There are 11 zeros that need to be in the beginning, and then followed by some other numbers, and the value has to be that or smaller. Okay, so this nonce searching is actually the Bitcoin mining process. So what happens when such a nonce is found is that the finder is awarded with Bitcoins. The block with the correct nonce is added to the blockchain, and the Bitcoin network works to mine the next block. Next, I will demonstrate the Bitcoin mining. Please look at the block 10 in the figure. So we have the previous hash, we have the timestamp, we have the TX root, and we have the nonce. Okay, again, we are at onlinemd5.com. For the screen, I have created a Bitcoin block. So we have the previous hash on this line over here. Then we have the TX root, which in this case, for the sake of simplicity, only includes one value which is not even hashed. So I have skipped some steps to keep this example understandable. So this is our one transaction. It is from Mika, that is me, to a student super foundation, and its amount of 1 Bitcoin. Then we have, so this is the transaction. Then we have the timestamp, which is 1604, and it's 16th of August 2018. This is when I'm creating this video. And now we start to search for the nonce. And as we remember, we have to find a nonce that is lower to particular threshold. So we are looking at the leading zeros in the string hash field over here. Now we just start to generate a random number, and we can do it like this. And pay attention to the string hash field over here. And let's see if we can find 1 zeros or 2 zeros. Let's see how far can we go. Okay, there was 1 zero. So after it took us 7 attempts to find a hash that starts with 1 zero. Now let's go for 2. Now this might take a bit longer. I have seen there was also 0, but no, it's not. No two zeros yet. Let's continue. Hello, welcome back. In order not to make this major boring, I cut out some of the video, but you can see that I have successfully found a hash that matches the precondition 2 zeros in the beginning. And it took me, let's see, how many tries is this? And that was actually 232 attempts. I pasted the number of ones to Microsoft Word and computed the number of characters there. So lesson learned. Nonce searching is computationally quite hard work. And so the Bitcoin actually uses a lot of energy simply to search for these nonces that are needed in the proof of work scheme. Okay, let's take a look at the proof of work schemes in more general. The basic idea in all such schemes is that we want to limit the requester by making things unnecessarily difficult. Things, I mean, what things, you might ask? Well, for example, adding a transactions to the ledger, for example. Proof of work schemes can be also used to fight spam. If we require that each message contains a hash computation result, this would not be a problem to the honest sender if it takes, for example, 10 seconds to compute the hash function result. But this would be a big problem to spammer that wants to send thousands or hundreds of thousands of messages. In cryptocurrencies, proof of work ensures that creating a malicious block or entire ledger is too costly. For example, a ledger where attacker has more money than the real one. Without proof of work, creating fake blocks or entire ledgers would be too cheap. Okay, we find ourselves in the core of the Bitcoin, in the Bitcoin mining, and we find that majority of effort to mine Bitcoin is purposeless. In other words, it's only needed to provide trust. In a perfectly altruistic and honest world, cryptocurrencies would not need such proof of effort. However, it has been noted that a protocol which does not impose cost on its users invite abuse. It has been argued that the so-called handicap principle explains incentive for honest communication between animals by making bluffing too expensive. Tail of a peacock makes the peacock more vulnerable to predators. In other words, it is saying, I have survived in spite of this huge tail, hence I am fitter and more attractive than others. To repeat, the Bitcoin system is secure only as long as honest nodes collectively control more CPU power than any cooperating group of attacker nodes. So, our trust on Bitcoin is based on the fact that the honest nodes control most of the computing power. Therefore, bluffing for them would be too expensive and also against their incentives, as they also own a lot of Bitcoins.